In this video, we're just going to go over one problem from each of the worksheets from Friday and Monday. So first we're going to go over one problem from optimization and L'Hopital's rule. So this is what the front of it looks like, but we're going to go over number 8. So with L'Hopital's rule, remember our directions are to find a limit. On the AP test, this is usually going to work on any limit problem. So remember, we always try direct substitution. When we do that, we get e to the 0 minus 1 all over the sine of 0. If we evaluate that, we're going to get 1 minus 1 over 0, which is 0 over 0. When we get some type of indeterminate form, remember this means we cannot determine it. That means we can apply L'Hopital's rule. And L'Hopital's rule says, in order to find this limit, we can look at the derivatives of both the top and the bottom. So we're not using quotient rule here because we're not finding a derivative, we're finding a limit. But we can take the derivative of the top and then the bottom separately. But then we're still applying a limit. So we're still going to then just apply direct substitution. So derivative of e to the 2x is e to the 2x times the derivative of whatever that exponent was. And so that's a 2. Derivative of minus 1 is 0. And then the derivative of the denominator is going to be sine of a function is cosine of the same function times the derivative of that function. So there's going to be a 2 there. If you can always simplify. And so now we're going to apply the same direct substitution. So we get e to the 0 all over cosine of 0. And anything to the power of 0 is 1. And cosine of 0 is also 1. So we get a limit of 1. If we were to get indeterminate form, like again, we would then apply L'Hopital's rule again. And there are some questions like that at the bottom. I believe maybe number 12 or number 13, I forget. So there's L'Hopital's rule. Now we're going to go over a question from Monday's assignment. It looks like this, optimization practice 1. And we're going to go over number 4. A rectangle has a perimeter of 80. Its width is x. The question says right here, find the maximum area. So that's how we know kind of that we're going to do calculus. And this is what we're going to take our derivative of. So we need an equation for area that only has one independent variable so that we can then take its derivative. So I'm going to write out some of this information here. So again, please remember, we always need to come up with this original equation, and it does need to correspond to the variables in our picture. We don't want to have extra variables. We really want to make this simpler. And I used x because it told me to. It didn't say what to use for length, so I just used L. But I can't really take the derivative of this guy here because we have two independent variables. So I'm going to use this secondary equation with using the information they gave me, and I'm going to solve for one of those variables. So in this case, they're really both just as easy, so you just pick one. So I guess I'll pick maybe L. So if we get L by itself, we're going to get this, and then if we divide everything by 2, we're going to get that L equals 40 minus x. And now we're just using the method of substitution. We're going to plug that in for L into my area equation. So instead of L, we're going to have 40 minus x, and then this x is still there. And now we have an equation with only one independent variable. That's what we're going to take the derivative of. We're going to prove that it really is a maximum, and then we're going to answer the question. So we could leave it like this and use product rule, or we can distribute so that we don't have to use product rule. So we're going to get 40x minus x squared. And now when we take the derivative, we're going to get 40 minus 2x. And again, we knew we were going to take the derivative of the area because that's what we're maximizing right here. If they asked me to maximize perimeter, then I would have come up with a perimeter equation and taken its derivative. So I accidentally marked that as the second derivative, sorry. Okay, so we want to set this guy equal to 0 to find those critical numbers. And if we simplify, we see that x equals 20. So that's a critical. We still need to prove that it really is a maximum. You can use either the first or the second derivative test. When your first derivative is a polynomial, you probably always want to choose that second derivative test. A second derivative here is just -2, which is always negative, meaning this guy is always concave down. So any critical numbers I get have to be a maximum. So remember, concave down looks like this. So x equals 20 is a maximum. Okay, and this right here is just us proving that our critical number is really a maximum. So now we just need to make sure that we answer the question. The question says, find the maximum area. And we have found the maximum, the width that will give us that maximum area. So now I need to find length in order to find area. So if I know the width is 20, I can plug that back here into that secondary equation, and I see that my length is also 20. And then since area is length times width, we actually have a square here to give us the maximum area. And our maximum area is going to be 400. Just make sure you include your units. Here we're looking at centimeters, so it's going to be centimeters squared. Oops. Sorry.